The spacecraft is no longer perfectly aligned with that safe, looping path home. What if Artemis II didn't come back? Not an explosion, not a failure you can see, just silence. A spacecraft drifting somewhere between Earth and the Moon, off course, off script, and slowly disappearing. Because in space, getting lost doesn't mean being stuck, it means never being found. Artemis II is supposed to be a comeback story, humanity's first crewed journey around the Moon since Apollo. 4 astronauts riding inside the Orion spacecraft, slingshotting around the lunar surface before returning safely to Earth. No landing, just a test, a proving ground, a promise that we're ready to go deeper. Everything about the mission is calculated. Precise launch windows, carefully plotted trajectories, a path called a free return trajectory, a natural loop that swings the spacecraft around the Moon and brings it back home. Even if everything else fails, that's the safety net, or at least it's supposed to be, because space doesn't care about plans. It starts small, a tiny miscalculation, a navigation drift so subtle it doesn't trigger alarms immediately. Maybe a sensor glitch. Maybe a thruster fires just a fraction too long. Maybe something no one on Earth even notices at first. Inside the capsule, everything feels normal. Earth is already shrinking behind them. The Moon, still distant, hangs like a silent target ahead. The crew moves through routine checks, voices calm, trained, focused. Then Mission Control notices something, a deviation. Not big enough to panic, not yet, but enough to ask a question. Orion, confirm your trajectory. A pause. Numbers are exchanged. Calculations rerun. The silence stretches just a little longer than it should. Because here's the problem. Space isn't forgiving. You don't turn around like a car. Every movement costs fuel. Every correction is a trade-off. And the further you go, the fewer options you have. Now the drift is real. The spacecraft is no longer perfectly aligned with that safe, looping path home. The free return trajectory, the one designed to save them if everything goes wrong, is slipping away. And this is where the tension tightens, because the crew has a choice. Do they fire the engines now and try to correct it? Or wait, gather more data, risk drifting further off course? Fuel is limited. Use too much now, and there might not be enough later. For re-entry, for stabilization, for survival. Wait too long, and the physics becomes unforgiving. Minutes turn into hours. On Earth, teams at NASA are running simulations at insane speeds. Thousands of possible outcomes, tiny adjustments, worst-case scenarios. Inside Orion, the crew can feel it. Not panic, not fear. Something quieter, uncertainty. They look out the window. Earth is smaller now, not a world, just a bright, fragile sphere suspended in endless black. And the Moon? It's no longer directly ahead. It's slightly off. Communication delays begin to stretch. Not huge, just seconds, but enough to remind everyone how far away they are. Every message is a question sent into the void, waiting for an answer that doesn't come instantly anymore. Orion, we recommend a course correction burn. Another pause. The crew runs the numbers again. And this is where the hidden problem reveals itself. The correction needed is bigger than expected, much bigger. To get back on track, they'd need to burn more fuel than planned. And that fuel, it's not just for navigation, it's for survival. Re-entry angles must be exact. Too steep, and they burn up. Too shallow, and they skip off the atmosphere, back into space. Or there is no margin for error. So now, the question changes. It's no longer, can we fix this? It's, what do we sacrifice to fix it? Time is running. The Moon is approaching. but not in the way it should. Instead of a clean, controlled loop, the spacecraft risks missing the precise gravitational window needed to swing back toward Earth. Miss it, and the trajectory stretches, wider, longer, more unpredictable, and suddenly, a terrifying possibility emerges. They don't come back in days. They drift for weeks, maybe longer. Mission Control makes the call. A critical moment, a last-chance decision. Fire the engines, or accept a new path into deep space. Inside Orion, there's no dramatic music, no shouting, just a quiet acknowledgement, and a hand moving toward the controls. So, what actually happens if Artemis II gets lost in space? The truth is, lost doesn't mean endless drifting. Not immediately, because missions like Artemis are designed with layered safety systems. That free return trajectory, it's the first line of defense. As long as the spacecraft stays within a narrow window, the Moon's gravity automatically sends it back to Earth. But if they drift too far off that path, everything changes. At that point, survival depends on fuel, timing, and precision. NASA can guide them back, but only if there's enough fuel for course corrections. Every second matters. Every calculation must be perfect. If they still have fuel, they can adjust. If they don't, they won't just float forever. They'll enter a new orbit, around Earth, around the Moon, or even the Sun, alive for a time. But with limited oxygen, water, and power, the outcome becomes inevitable. The mission doesn't end with an explosion. It ends with resources running out, in the quietest place imaginable. And that's what makes space so unforgiving. Not the fire, not the launch, but the silence when something goes just slightly off. A mission like Artemis II isn't just about reaching the Moon. It's about threading a needle across hundreds of thousands of kilometers, with no room for hesitation. So when you look up at the night sky, that tiny point of light could be a spacecraft carrying human lives, balanced on math, timing, and trust. Do you think we're truly ready for missions deeper into space? Or are we still one small mistake away from getting lost out there? Let me know what you think.